So now we're going to talk about the YOLO V7 model and the architecture, and then we're also going to talk about like some of the advantages. What are they doing different with the YOLO V7 model compared to, for example, like YOLO V5 and those kind of things. Like what are they actually doing to increase the performance of the model without like increasing the number of parameters and also like slowing down the inference speed. So basically, like YOLO stands for you only look once. So the YOLO V7 model here is a single stage object detector. So basically, first of all, when we take in an image, for over here to the left, we have our backbone. So we take our image, we throw it into our backbone. And the purpose of our backbone is to extract features in our images. So we basically have like these feature maps here. So we have these C's here, which is the feature maps in our images. And then we basically just have this backbone. We're feeding our image through, and then we just have these different kind of like feature maps in our backbone. So in the backbone, we try to learn the features that we have in the images. So this is really good because then we can actually like have a lower dimensional representation of our images. We can just find the exact things that we want in our image. So let's say we want to detect like cats and dogs, then we might want to find like features describing like cats and dogs in our backbone, and then we can make like a lower dimensional representation of our image. So after we have found our features and feature maps in our backbone, we actually like pass it through our feature pyramid network, which is basically also just a network containing like features, but we have this pyramid structure. So we actually like have some like higher like dimensional like features. We have lower dimensional features, and then we have like this pyramid structure where we basically just go from the backbone. We find features in our backbone, we feed them into our feature pyramid network, so we actually like get higher accuracy. And it also like it just learns what to pay attention to in our images and what features are actually like important. And then we'll have like these feature pyramid layers. Then we need to just feed those into our head layers, which will actually like do the detection of our objects. So we have our backbone, which is kind of like the same. So we have the backbone for feature extracting together with our feature pyramid network, and then after that we're actually like going over to the both the classification and also localization of our object. So we have the features, but now we want to have these heads here that can detect individual objects in our image, and then we basically just have a head for each of the individual objects. We just have a head trying to find the location in the image and also the type of class that we have inside of that location that we find. So we basically just have our feature pyramids. We have the bounding boxes that we want to draw. We want to localize where are those bounding boxes for our heads, and our heads will actually like be the classes that we want to detect in our object detector. And then after our head here, we'll just have our YOLO loss. So we basically just calculate the loss so we can then train our neural network to perform better on object detection, both for localizing the exact position of our object, but also the class type of our object. So we both have like the cross entropy loss, we have L1 loss, and then we also have objectnet loss. So we both like want to find the correct class. We want to get better at finding the correct class and also be more accurate in finding the location of the actual object, so we can place the bounding box exactly on top of the object that we want to find for each of the heads in our YOLO V7 model. So down at the bottom here, we can actually like just see the different kind of like convolutional layers that is going on. Later on, when we're actually like going to load in our model, we're going to get a summary of our model so we can see exactly these things going on. So we basically just have like some convolutional blocks trying to find features in our images. We also have some upsampling blocks, and then we'll have our feature pyramid network, where we basically just have like, again, we just have these convolutional 1D layers. We have a convolutional block as we have in our backbone. And then we basically just go like from these upsampling techniques. So we have like a really low dimensional like feature network, and then we can just upsample those blocks so we get like higher resolution with the same features. And then we can just pass those into our head, do object detection with convolutional layers as well. And then at the end, we'll like have our classes and boxes, which should actually like be some kind of like MLP doing all these different kind of things. Again, we just calculate the loss at the end, and then we just train a neural network with backpropagation as we're doing with all the other different kind of like models.